Okay, I hope I'm audible to all my students who are attending this particular lecture for the introductory mathematical methods for economics course. In this particular lecture, I'm going to start with the discussion of the 2024-2025 question paper for the introductory mathematical methods for economics. This exam was held in the month of January 2025, and this is for all those students who are pursuing BA Honors Economics from University of Delhi. Okay, so all students can see the question paper on your screens. Okay, this course is offered in the first semester of BA Honors Economics at University of Delhi. So students can all find the details in front of you. This is BA Honors Economics, DSE 1 paper, Introductory Mathematical Methods for Economics course. Okay, so in this particular lecture, I'm going to start with the discussion of the problems from this particular question paper, starting from problem number 1. Okay, you can clearly see the format of the question paper. Okay, scientific calculator is allowed, first of all, and you need to answer the question paper in one language. It can be English, it can be Hindi, but whatever language you are following should be maintained throughout the paper. Okay, and then question, the first one, students can see that we have to attempt any 9 questions. I will be solving all problems in my lectures, but students can of course follow the choice. If there is any internal choice, students can take advantage of that choice. Okay, so let's quickly start from the discussion of question number 1 in this particular lecture. So let's look at question 1, part A. Find the equation of the tangent line to the graph x square plus y square whole cube equals 8x square y square at the point minus 1 comma 1. Okay, so we have covered this in our lectures on single variable differentiation. Remember, access for all my lectures is given to all those students who have subscribed to my complete course for the introductory mathematical methods for economics course. So in my lectures on single variable differentiation, we have talked about how to find the equation of a tangent given a function and given a reference point. So if I quickly come to the whiteboard to solve this, I am writing the main heading for completeness. We are looking at Delhi University exam 2024-25. Okay. The exam happened in 25, but students have been studying this course throughout 2024. Okay. So the name of the course is Introductory Mathematical Methods for Economics. We call it Introductory MME. Okay. And this lecture is recommended for all those students who are pursuing BA Honors Economics from University of Delhi. Okay, so we are looking at question 1, part A. We are given the function. Okay, so the function which is given to us, I am just writing that function for reference. So we are given that f of x is equal to, let me come back to the whiteboard. So it's an implicit function. So let me write the implicit form. X square plus y square whole cube is equal to 8x square y square. So it's an implicit function. X square plus y square whole cube is equal to 8x square y square. Students can see it's an implicit function. When I say it's an implicit function, it means you can't separate x and y. You can't write y in terms of x. It's an implicit function. Okay, so we need to find the equation of the tangent. We need to find the equation of the tangent at the point minus 1 comma 1. Okay, so First of all, recall from my lectures on single variable differentiation. Recall from my lectures on single variable differentiation. That the equation of a tangent to the function y equal to f of x at the point x0, y0, which is your reference point, is given by y minus y0 is equal to f dash x, or I can say dy by dx times x minus x0, where dy by dx itself is evaluated at the reference point x0, y0. Now you will find all this in my lectures on single variable differentiation. Y minus y0 is equal to dy by dx, is the slope evaluated at the reference point x0, y0 times x minus x0. Now, first of all, we are given x0 and y0, right? So my x0 is -1 and y0 is 1. Now, first of all, I need to find dy by dx. Given this implicit function, I need to find dy by dx, and then I have to evaluate dy by dx at -1 and 1. So let's quickly do that. Erasing all this off. Let's now find dy over dx. So we are given this equation. So differentiating the above implicit function, with respect to x gives us, let's differentiate. If I have to differentiate the left hand side with respect to x, how do I do that? It's 3 times x square plus y square to the power 3 minus 1. I use the power rule, times the derivative of x square is 2x. The derivative of y square is 2y times dy by dx. Students who are watching this lecture, you should have watched, first of all, my lectures on single variable differentiation, or you should have idea about implicit differentiation, which you must have even done at high school level, if you had maths at high school. We have used the power rule of differentiation. Remember, the derivative of x to the power n is just nx n minus 1. So first of all, the derivative of x square plus y square to the power 3 is 3 times x square plus y square to the power 3 minus 1. And internally, if I differentiate using chain rule, the derivative of x square is 2x, the derivative of y square is 2y times dy by dx, because y itself is also a function of x. Okay, and now I differentiate the right hand side. So 8 times, I'm going to use the product rule within this. Product rule of differentiation. So x square times the derivative of y square is 2y times dy by dx, because remember, y is the function of x, plus y square times the derivative of x square is 2x. Okay, so this is the product rule of differentiation which we have used. If I continue forward, it's going to be 3 times x square plus y square whole square times 2x plus 2y times dy by dx is equal to 8 times 2x square y dy by dx plus 2xy square. And now I can just open up the brackets if I erase this initial portion off. So I can now open up the brackets. So it's going to be 3 into 2x is 6x times x square plus y square whole squared up plus 3 into 2y is 6y times x square plus y square whole square. X square plus y square whole square times dy by dx. So basically this into this gives me this, and this into this gives me this. Equals 8 into 2x square is 16x square y dy by dx plus 8 into 2xy square is 16xy square. Now all I have to do is I have to collect all the dy by dx terms together. So if I erase all this off, I can collect all the dy by dx terms together. So 6y times x square plus y square square times dy by dx minus 16 x square y dy by dx. Basically, I bring this to this side is equal to 16 xy square minus 6x times x square plus y square whole square. Basically, I took all the dy by dx terms to one side and all the other terms to the right hand side. Now on the left hand side, I can take dy by dx common, which gives me 6y times x square plus y square square minus 16x square y is equal to 16xy square minus 6x times x square plus y square whole square. And now I can finally write dy by dx. So if I erase, students need to solve this along with me. So erasing all this off, let's look at dy by dx. So our dy over dx comes out as 16xy square minus 6x times x square plus y square whole square over 6y times x square plus y square square minus 16x square y. And now we can evaluate dy by dx at the point minus 1 comma 1. So if I erase all this off, let's evaluate dy over dx at the point minus 1. That means I put x as minus 1, y as 1. So it's going to be 16 times minus 1 times 1 square minus 6 times minus 1 times minus 1 square plus 1 square whole square over 6 times 1 times minus 1 square plus 1 square times squared minus 16 times minus 1 square times 1. So this comes out as 16 into minus 1 is minus 16. This minus and this minus makes it plus 6 times. Minus 1 square is 1. 1 square is 1. 1 plus 1 is 2. 2 square is 4. Over 6 times minus 1 square is 1. 1 square is 1. 1 plus 1 is 2. 2 square is 4. Minus 16 times minus 1 square is 1. So I get minus 16 plus 24 or 24 minus 16, which comes out as 24 minus 16 is 8. Denominator is also 8. I get dy by dx as 1. So I'm writing it here. Dy by dx evaluated at the point minus 1, 1 comes out as 1. Now all I have to do is just directly use the formula. So if I erase this particular portion off, what is the formula? Equation of a tangent is given by equation of the tangent is y minus y0 is equal to dy by dx evaluated at the reference point x0 y0 times x minus x0. Now all I have to do is just plug in the value. So if I erase all this off, so I get y minus, what is y0? 1. What is dy by dx? 1 times x minus, what is x0? Minus 1. So I get y minus 1 is equal to 1 times x plus 1 which implies y minus 1 is equal to x plus 1. So what is y? X plus 1 plus 1, which gives me y equal to x plus 2. This is my answer. This is the equation of the tangent. Y equal to x plus 2 is the answer for this question and is the equation of the tangent. So hoping all students have understood how we have solved this. All we had to do was we had to find dy by dx and we had to use implicit differentiation to do it. Now I repeat again, students should have watched my lectures on single variable differentiation, or if you have maths at high school level, then you would have done implicit differentiation at the high school level as well. Remember the maximum benefits you get when you subscribe to my complete course for introductory mathematical methods for economics. Just doing the past year papers is not enough. In my lectures, you will see that I have done good practice of implicit differentiation before solving these past year papers. Okay, so now let's look at the second problem. If I come back to the question paper, we are done with part A. Now let's look at part B. So part B is telling us to estimate the maximum error. Estimate the maximum error when approximating f of x equal to square root of x with a second order Taylor polynomial about x equal to 4 in the interval 4, 4.2. Okay, so we need to estimate it in this particular interval. We need to find the maximum error. Now again, students who have done my lectures on single variable differentiation, we have talked about the Taylor's formula. We have looked at the Taylor's formula about x equal to 0. Or in general, we can also talk about Taylor's formula about x equal to a. So if I come back to my whiteboard, we are looking at question 1 part B. We are given that f of x is equal to square root of x. We are given that we need to find the error term. It's a Taylor's formula about x equal to 4. Okay, and we are also given that x belongs to the interval 4 to 4 point. We need to find what? We need to find the maximum error. We need to find the maximum error. If I come back to the question paper again, we need to find the maximum error when we are approximating this function with a second order Taylor polynomial about x equal to 4 in this interval. Now, first of all, remember the Taylor's formula. Recall from my lectures on single variable differentiation. Recall from my lectures on single variable differentiation. Okay, the Taylor's formula. The Taylor's formula about x equal to an arbitrary point A is given by f of x is equal to f of a plus x minus a times f dash a plus x minus a square over 2 factorial times f double dash a plus x minus a cube over 3 factorial times f3a. f3a means f the third order derivative plus dot 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 xn over n factorial x minus a. Let me correct myself. It is going to be plus dot dot dot. I have, let me write it clearly here. It's going to be plus dot 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 x minus a to the power n over n factorial times fna. And then I have the error term plus x minus a to the power n plus 1 over n plus 1 factorial times the n plus 1th derivative of the point C. This is my error term. The last term is my error term, so I can circle it. This is the error term. It's the error term, or think of it as the remainder, where C lies between 0 and x. C lies between 0 and x. So this is the Taylor's formula. This is the Taylor's exact formula, which I had covered in my lectures on single variable differentiation. I repeat, f of x is equal to f of a plus x minus a times f dash a plus x minus a square over 2 factorial times f double dash a or f2a plus x minus a cube over 3 factorial times f3a. When I say f3a, it's nothing but the third order derivative. I can write f triple dash a like this on the top. f3a is nothing but f triple dash plus dot 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 x minus a to the power n over n factorial times fna plus my remainder term or the error term is x minus a to the power n plus 1 over n plus 1 factorial times fn plus 1 c, where c is a number lying between 0 and x. Now we need to only focus on the error term because we need to find the maximum possible error. That means from now onwards, I'm erasing all this and only focusing on the error term. So I'm writing it again here. The error term is given by the following. It is given by x minus a to the power n plus 1 over n plus 1 factorial times fn plus 1 c. Okay, this is the error term. C is a number which will lie between 0 and 4 because remember C lies between 0 and x. What is x? 4. So C lies between 0 and 4. Okay, so now first of all, it is about x equal to 4 means what is going to be my term here? What is going to be? So if I come back to the question paper once, it's a second order polynomial. When I say second order, it means it's going to go on till 2 and the error term will be 3. Okay, so the second order Taylor polynomial means f of x will be equal to f of a plus x minus a square over 2 factorial times x plus, let me correct myself, it's going to be f of a plus x minus a times f dash a plus x minus a square over 2 factorial times f double dash a. Till here is the second order. Now we also have the error term plus x minus a cube over 3 factorial times f triple dash a or f3a. So guys, my error term is this for a second order polynomial. This is the error term. This at the bottom, this was the error term in general for an nth order. For a second order, the error term, this is the error term. Error term for second order Taylor polynomial. This is the error term for a second order Taylor polynomial. X minus a cube over 3 factorial times f3. So now I can erase this also. And I'll only focus on the error term. That means my error term will be x minus a cube over 3 factorial times f3a. Okay, so now what is going to be my x minus a? So now we need to solve for this. So let's first of all find out the third derivative. Given the function f of x, we need to find the third derivative. So let's quickly work on that. So It's going to be, so first of all, about x equal to 4 means a is 4. When I say about x equal to 4, it means a is 4. So this is going to be x minus 4 cube over 3 factorial times f3 c. Because the error term involves c. Remember c? In green color, it involves c. It involves c here. Okay, so actually this is also C. Let me correct myself. The error term always contains C. It's F3C. Now, first of all, let's find the third order derivative. Let's work out the third order derivative. So, what is f dash x? If I differentiate square root of x, I get 1 over 2x to the power half using the power rule. If I find out f double dash x, it's going to be half into minus half. X to the power minus half minus 1, which means minus 3 by 2, comes out as minus 1 by 4, x to the power minus 3 by 2. This is my f double dash x. What will f3x be? Differentiate this again. So minus 1 by 4 times minus 3 by 2, x to the power minus 3 by 2 minus 1. Comes out as 3 by 8, x to the power minus 5 by 2. So if I erase this initial portion of f dash x, if I erase this off, my f3x finally comes out as 3 over 8. X to the power minus 5 by 2, I can take it in the bottom. It becomes x to the power 5 by 2. This is f3x, guys. So what will f3c be? If I erase all this off now, f3c will be 3 over 8. 3 over 8 times c to the power 5 by 2. This is going to be my f3c. So what will the error term be? X minus 4 cube over 3 factorial is 3 into 2 into 1, which is 6 times f3c is, plug in the value, 3 over 8c to the power 5 by 2. So this comes out as 3 over 6, 8, 48. Numerator x minus 4 cube. Here we have c to the power 5 by 2. This is my error term, guys, which I can call as R3x, the remainder term. For a third order, for a second order Taylor polynomial, my error term is R3x, which is 3 by 48, x minus 4 cube over c to the power 5 by 2. Now I want it to be maximum. It is maximum when x takes the maximum value. Now x belongs between 4 and 4.2. The maximum is 4.2. Put x as 4.2 in it. And put c as 4, because c lies between 0 and 4. The maximum it can take is 4. That means, what is my answer? The maximum error is 3 by 48. Instead of x, I now put the maximum value it can take, which is 4.2. Minus 4 cube over c. The maximum value c can take is 4. So when you solve it, you get 0.008 over 5, which is your answer. I mean, you can simplify it further if you want. So the maximum error is 0.008 over 500. Remember, the error is maximized for highest possible value of x. And c lies between 0 and 4. The maximum value c can take is 4. So when you plug c as 4 and x as 4.2, your error is maximum. So hoping all students have understood how we have solved it. I stop in this particular lecture. We have solved question 1 parts A and B in this lecture. In the next lecture, I'm going to start with the discussion of question number 2. So I hope all students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolofeconomics@gmail.com. This is where I stop in this lecture.